So now in this video I thought I would just do a quick demonstration of what I think is a really cool circuit. All you really need is, in this case, a JFET transistor. This is an N channel, J310 right there, and the pin layout is drain to the left, the source to the middle, and the gate to the right. So 1, 2, 3. The gate actually controls how well the drain to source conducts. And so we're going to put the gate to this jumper that goes to the negative rail, and the source to that other jumper, that middle jumper, and the drain up here. It's just floating right now. And so here we have a trimpot, and I'm going to actually turn it up, and so there's a lot more resistance than we need, but this trimpot fits into the breadboard really nicely. So we got the 3 pins. The wiper, the knob here, is connected to the middle pin, and we're going to connect that other jumper there that goes to ground, and that's one end of the resistive element. There's 2 pins that connect to the ends of the resistive element, and the wiper slides across there. And so now it's a variable resistor. We got about 5,000 ohms of resistance if we put it there. If we go all the way to 0 ohms, which you should usually avoid, but there's nothing to the positive there, so we don't have to worry about that. Plus the component will probably limit current enough to protect it anyways with 5 volts. But in case, now we got about 0 ohms of resistance. So we're going to go up to 5,000. And what we're going to do is actually set a current. And so we're only dealing with 5 volts at the power supply right now, as you can see. And no current's flowing right now. We just completed the circuit. But as I turn resistance down, so a 1 kilo ohm resistor, trimpot I should say, would work better. But these 10 kilo ohms that I have fit in the breadboard really nicely. So I just keep lowering the resistance until I get a current that I like. And we're actually setting the current that the transistor here will output. So we got 11 now. That's good enough. I wanted 10, but that's good enough. So here's the cool thing. So that is with the transistor. Usually when you put some more components in series, the current drops down because they're blocking voltage and stuff. And but when we're setting this as a current sink, and so usually if you set a current, you call it a current source, but technically if the component setting it is on the more negative side of the circuit, then you consider it a current sink. That's more accurate, but you might still hear it called a current source. So I'm putting the long lead, the anode of the LED, up 1 row, short lead, the cathode to the drain of the transistor. And here is what is cool about this. Now we also have the transistor, and there you can see we have practically the same current right there. And now it is the same. So for some reason this isn't completely accurate. A multimeter would be more accurate. But there you can see we have the same current whether we go through an LED or just the transistor itself. And now we're only dealing with 5 volts though, so green LEDs, they block a little bit more voltage. So unfortunately, now you can see we got a little less current right there. But we can fix that. So it blocks about 1 volt more than the red LED. So once we go up to 6 volts, there you can see we have that 10 milliamps. And so this is 1 amp, 100 milliamps if it was a 1, and then 10 milliamps. And then that's the single digit. So if that said 1, it would be 1 milliamp. And so in case, we're going to plug that. And again, if we add another LED in series with the voltage we have now, so we got just enough voltage to light the green LED at 10 milliamps. Again, you're going to see we got the 2 LEDs. Now we're blocking. Green LEDs are just naturally brighter. They're passing the same amount of current, which is 5 milliamps right now. And so we're going to up the voltage by 2 volts. Because it's a red LED, it takes about 2 volts to start conducting. And that's what it blocks from everything else. And there you can see, we got that. So, if we want another green LED, we'll have to go up 3 more volts. So let's just do that now. 3 more volts, or more even. So first we'll look at the 3 more volts. So I got to put this in series with the red LED. And now we'll look at the 3 of them. 10 milliamps. 2 of them, 10 milliamps. 1 of them. It looks like it went up a little bit. It does change slightly. Plus, as I said, and there you can see 10 milliamps through the transistor. So there are some factors that kind of change it, and this power supply is not an accurate current meter down to the milliamp level. It's made for the amps. But again, if we want another LED, we have to up the voltage again. We know it's going to be 2 volts because we've only been raising the voltage that we need so far, and so we can go up 2 more. But the main takeaway is, even if we bypass a bunch of components, we set the current, and as long as you got enough voltage, it's going to give you the current that you set. This is kind of high voltage, though. I don't really want to keep it directly across the transistor for much time, because then it's got to dissipate all the power. But in any case, it's set to current really nicely, even as the voltage change, even as the load changes. So thanks for watching. I'll post some more videos that you might find interesting here. Make sure you subscribe and click the bell, and I will see you in the next video.